So for this problem, we're going to remember that if you're going to choose to use Desmos, it's pretty straightforward, but you need to remember that you are adding a table, right? So make sure that you're adding your table. And then you're going to type. I'm going to switch. I'm going to try to make this double screen so that I can have side by side. So I can see my values. There we go. Make you over here. Scoochy scooch. Squeeze in. No. Okay, cool. Didn't want you to squeeze in anyway. And then I'm going to go to Desmos. All right. So now I'm in Desmos. I'm going to add a table. To add a table, I press the plus sign. I'm going to go to table. And I'm going to type in the values that I have. So 15, 20, 25, 30, 35, 40, 45, 50, 60. You get it. 75. And now I'm going to type in my Y values, 24 and 4/10, 27 and 9/10, 30 and 5/10, 31 and 7/10, 31 and 2/10, 31, 31 and 6/10. Got to scoot over my thing. At 50, 32 and 4/10, 32 and 4/10. 31 and 4/10, 29 and 2/10, and 26 and 8/10, and 24 and 8/10. Okay, checking with your peers. How are we feeling about inputting this into Desmos? Where are your notes? They're on your notes. Take them out. Find them. From last week, last Thursday. Folder, notebook, with your notes. That makes sense.
Where's that graph?
We just added the table and put those values.
I mean, so was the second table or?
They're one big table. Okay, so the first question it says, which is my most appropriate? So I'm going to go over to my graph. I'm going to expand here. Oh no, it didn't work. I see nothing. Oh, the horror. Okay, no. What does that mean I need to do? I need to change my values. I need to adjust my window. So I know everything is positive. So it's in quadrant 1. But when I look at my values, I can tell that my X value, my X max should be at 75 and it's currently at 18. So I need to change this value. I'm going to just go ahead and put it up to 100. Okay. The next thing is I'm going to look at my Y values. My highest Y value is 32. Currently is at like 10 and some check. Well, almost 20. So I'm going to change that to, let's put it at 50. What this is doing is ensuring that I can see my values. Do I see my values now? Yes. If I don't make that adjustment, I'm going to think I did something wrong. Huh? I changed my values so I can see. Okay. Zooming in and out does show it, but zooming in and out can over exaggerate your view, right? If you zoom too far out, my necklaces are tangled and I'm choking. If you zoom too far out, it can look like a linear equation, or it can look like something that it's not. So that's why it's important for you to be comfortable to change the values. All right, now step 1, question 1. Does a quadratic look like it would fit this data? Yeah, for the most part, yes. What would be a problem? There's a dip, right? So that's what step 1 is asking you. Does the quadratic fit this model? And the answer is yes. However, there's a little dip in the graph, right? Yes, but there is a dip in graph. In graph, well, in points or. Okay. All right, it says determine the quadratic regression equation for this data set, then analyze the residual plot. So your quadratic equation, remember for Desmos that there is a model you have to type in, right? So for Desmos, it's going to be our y1 squiggle ax1 squared plus bx1 plus c. Okay, that's the model I have to type into Desmos in order for me to get my graph, right? If I'm going to be using Desmos, I need to know these models for linear, quadratic, and exponential, which we took in our notebook on page 15, I think. So now I'm going to go to Desmos and I'm going to type in my regression model. So come over here and I'm typing y1 ax1. I'm going to press shift 6 to get the square plus bx1 plus c. Only the x is squared, only ax squared, a term is squared. Okay. Was that terrible? So it said to find your regression equation, found it. And then it said determine a quadratic regression equation for the data set, then analyze the residual plot. So your residual plot on Desmos literally just means, you see where it says residuals? You press plot. And now you're allowed to see your residual plot. Your residual plot is saying, how does it interact around the x-axis? So when we talked about residual plots, we want it to be close to the x-axis, but evenly on top and bottom or on the line. Do you remember that? If it's on the line, that is a perfect model, right? But if its points are evenly above and below the line, then it is a good model. Not perfect, but good. So looking at our residuals, this is a good model, not perfect, but good. Okay, yes? Yes.
Last weekend I fill in the notes, based on the company notes on the model for that. So I just wanted to know if you see anything.
Yeah, I did more by hand last year. Yes.
So is that okay with you?
All right, so our regression equation. So to write our regression equation, to my understanding for College Board, they're gonna have you round it to the nearest thousandths, which is 3 decimal places. So if it says round to the nearest thousandths, that means how many decimal places? 3. So we're rounding to the nearest thousandths to create our regression model. So our regression model here is going to be y equals negative 0.008 x squared plus our b value is 0.735 x. And then our C value plus 16 point. I think I have a number different than y'all.
It's the 31. You put a second 31.
This is 31.4. Thank you. I was like, I think my numbers are different than y'all's. 7.3. So this should be 7.40. And this should be 16.030. Yes. So that's my regression equation. My approximate regression equation. So that's what I'm writing in that box. Yes? Is that doable?
I put that equation in last, maybe I grabbed it.
Okay. And my residuals are close to the x-axis. And evenly above and below. So this is a good model. What is another way I can tell if it's a good model? I can look at the what value. Your R squared, and my R squared is close to 1. It's not at 1, but it is still fairly close to 1. Do we see that? So my R squared, my correlation coefficient is 0.9189, which is close to 1, fairly good model. So then that's my other clue that this is a good model, not a perfect, but a good model. Okay. Now that you have your approximate value of your regression model, it says, what is the maximum value of your quadratic regression equation? And what does this mean? So my maximum value means that I'm looking for my what? My vertex. Good job. So I'm looking for the vertex of our model. So when I come over here, I have 2 graphs. I don't want this one on, so I'm going to click to turn it off. So you see right here, all I did was press the circle, and it did what? Turns it off, right? So here's our approximate graph, and I'm going to find its vertex, and its vertex is at 46 and 25 hundredths. So what does that mean in regards to this problem? What does the 46 represent? My what? My miles per hour, my speed, right? And then what does the 33 represent? My miles per gallon. So the max speed that I can be going to get my max miles per gallon is what? 46. That's what it's asking you. Oh, so when it says, what is your vertex and how does it relate to this problem? My vertex is at 46 and 25 hundredths. And what was the Y value? What's my Y value? 33 and well, so in regards to this problem, that means that your max speed is 46 and a quarter miles per hour. And it will use how much? 33 and 1400 miles per gallon. Does that make sense? So if I'm trying to maximize the gallon, the gas that I have, this is what I'll have to be driving. Okay, the last part is given a value. So it says using this model, what would be the estimated for a typical mid-sized car going 55 miles per hour? So we've talked about how on here, there's a couple of ways to find it. If you're using Desmos, you would click on the graph and you would go to 55, right? And I'll get there. Oh, found it, right? That's option number 1. Option number 2, I literally just learned it last week in training. Crazy. You press this little gear button and it'll give you a table and you can just type it in. So again, you go to the function, click the gear, press the table, and type in whatever you need. And it will find it. So still at 32 and 53. So the answer to that part is saying, so if I drive, based on this formula that we have, if you drive 55 more miles per hour, you're going to be burning 32 and a half miles per gallon. Does that make sense? Yes? Doable? All right, so that's it with Desmos. Any questions about Desmos? Okay, on your thing, I would make sure I've written down my Desmos models for quadratic, linear, and exponential. All right. Which part? Yeah. Okay, so what do we get here? I forgot that quick, my brain. 32.53 miles per gallon. Okay. Yes. Questions about Desmos? All right. So now